Hi, my name's Mark McCool. I'm an instructor with the Casper College Machine Tool Program. It's a little loud, pardon the background noise, but we have things happening in our shop right now. Let's take a tour. So as we wander around the shop, you can look and he'll pan, we'll see all these different lathes over here. We have the same type of machine, just different brands. Once you learn how to run one of these smaller ones, you could jump onto one of the bigger ones way in the back over here. The function is the same. I like to spend a lot of time here because we are a natural resource state, and a lot of the work that we do in here will definitely transfer over to the jobs that we have to offer in Wyoming. Let's go back over here and take a look at what this gentleman's working on.
All right. What's he working on here?
What are you working on, Jonathan?
I am working on a vise. I'm boring out a hole for the moving jaw on a vise. He has a moving jaw right there.
The other component that will fit inside his vise here, so we're making sure we bore that casting so that it fits this, so we can finish up his components.
Awesome, very cool.
This machine right here is probably 60 to 80 years old, somewhere in the neighborhood. I don't know. It's World War II vintage.
Oh goodness!
But it's a very nice machine.
So what is it that still keeps it like a decent working machine? I mean, what does this technology change very often, or is it still pretty much the same as it used to be that far back?
That's a great question. The technology is essentially the same. The machine still rotates. You put your parts inside the chuck, and you use these axes, these travel points that you can go ahead and make the cuts on your part. All of these machines that you see here, these are probably 2 and 3 years old right here, and these function the same way.
Okay.
They truly function the same way. An addition that we have on some, if you want to come in and look at this, these are called digital readouts. You can actually move this. As I move the handles, you can see the values changing.
Okay, so this is connected to this piece right here.
This is connected to here, and you could actually control 4 decimal places out how close we get to our final dimensions, tolerances.
So just for more accuracy,
yes,
and that sort of thing.
So we work on making sure everybody understands that. We do a lot of threading. Again, threading is big in the state. And over here we have our manual milling machines.
Okay.
These manual mills typically work on more flat and square stock. The lathes in front of us here work on a lot of round parts.
Okay.
But you can do work on both, on either areas. Some of the chucks are that shape. Let's go back over here and look at that part. You can see what I mean about the odd shape.
Okay.
Are you about done with that depth?
What?
Are you about done with the depth?
Yeah.
When you are, stop the machine so we can show the shape.
Okay.
So while we're waiting for that, what kind of skills do you need to get into this profession? Like, what are some things that kids should be trying to kind of get a head start with if they're looking to do what he's doing right now and to get into this workforce?
I like to make sure we have a little foundation of some math, some good hand-eye coordination, because what we're trying to go ahead and do is create things with our hands, using our thoughts and processes to make sure that things come out. And first and foremost, it's safety. So common sense is a huge, huge bonus, what we have. If you look at what he's got here, that's not a round or a square part. It's just the shape of a vise. And what we're trying to do is go ahead and get it as true as we can, because these outside surfaces, you don't have anything really good to land on and clamp on. So what we've got is all these other operations to get it to where he is now, and hopes that we get this vise working out really well. So as we wander around the shop, again, different sizes of machines, but all these function the same. In here we have 2 CNC machines.
CNC machines.
Computerized numerical control.
Okay.
We have 2 here. If you follow me, turn this around so you can see.
Oh, there we go.
And you can see what's over here on this one. So, this machine is those on steroids. This one here are these machines on steroids.
Okay.
You can program, and these machines do exactly what you tell them to do. If you figure out your numbers wrong, it's going to have an accident, right? You don't want that. So we have the ability to go ahead and create a program, put it on a simulator, verify if the path is correct. If the path is correct, then we can put it into the machine, turn it on, there's your part done.
Oh, wow.
It kind of works because we've got an ability for the tools to come back up in here, different drills and end mills, to do the work that we need to do to get our finished part. Everything we're doing is we're typically removing material from something to get that finished shape and part.
Okay.
Okay? Very cool. Some of these machines have digital readouts as well. They are kind of slang nicknamed DRO. So if I do this and move, I can move this, create a zero, a reference point, and I have the ability to go ahead and carry this out 4 places once again on this machine. I can work out with both axes here and really control the fine adjustment that we need. This is the kind of fun stuff people look at and think, oh, can I make this here? Well, this actually is something that the instructor that teaches his CNC programming classes, he made a set of these for an old car he has at home.
Okay.
And he made them on this machine right here.
Oh, wow.
So we have the technology, so to speak, right?
Right.
We have the ability. We have the instructors to work with you to make sure everybody understands how to.
Yeah.
Yes, sir.
So just to give it a little bit more context, then we're looking at something that has practical application in a lot of different things, not just like
Absolutely.
energy industry, right?
Not
Like,
just the oil field. I mean, a lot of things now. Kids watch these shows. I mean, I watch some of them. You know, these car fabrication shows, motorcycle fabrication. They do a lot on these machines, and so we can show you how to go ahead and implement the programming part and the application part to the machine to get the final product.
So how long does this program normally take?
You can go for a certificate, which is typically a 1 year, 2 semesters with a lot of manual, some CNC. The full degree is a 2-year program, and I have you a few more semesters in here, and we also have an additional programming class for you in there. We spend time with CAD software, computer-assisted drafting, CAM software, computer-assisted machining. I teach a print reading class, some metallurgy, and some math for manufacturing. And again, that's all kind of encompassed in the certificate. The degree has a little bit more of the CNC components and an extra semester over in the machining. So we try to cover all the bases so they're ready to get out in the workforce.
Right. So in terms of the kind of, let's say, quality of life, right? Like, is this a good paying job? Like, once you get out there, you know, is this something that has a high ceiling, or is this something that you kind of get into one type of position and you're kind of set for life? Is that kind of how it works?
That's an interesting question. I mean, I'm biased because I did it for 34 years before I came up here and started teaching. So it was good for me. It allowed me to travel. I started in California, Oregon, ended up in Thailand.
Oh,
so
wow.
For me, it was a great opportunity. Came back to Nevada, then Colorado, then here. So I got a lot of chance to travel. As far as the ladder, if you will, as far as maybe moving from a manual to here, that is open. What we show you, we give you a foundation that you can go ahead and go into somebody's shop, and they can put you into a position, given the knowledge you come out of our program with, and you have the ability to kind of gradually find where you seem to fit in. Could it be just strictly manual? Could it be on the CNC? Could it be programming the CNC? Only setup on the CNC? You could get into the inspection side. There's a lot of avenues that you could do in this field. And the pay, again, it's a great opportunity if you like making things with your hands.
That's
it
awesome.
Really is.
And lastly, just to be respectful of your time, what would you say to somebody who's on the fence about the trades, who hasn't really considered the trades and wasn't even in their frame of,
Please come and talk to me. Look me up on our Casper College website. Call me up. Come in and set up an appointment to take a tour of the shop. I'd be more than happy to come in and let you see everything we have. Because I tell you what, we have fun in here, number one, because I want to make sure that people enjoy coming in here. Number two, you're going to learn a lot. And it's kind of a fun environment to kind of create something with your hands.
Awesome.
Okay.
Thank you so much for
You
your
bet.
time. Really
You bet.
appreciate it. Let's end on this one.